Good morning, friends. Today we are going to start the next type of plastic molding process. So in the previous class, we have studied the molding processes for thermoplastics. Out of one more is remaining, that is rotational molding is remaining. Today we are going to see compression molding, transfer molding, and then the rotational molding. Now, this process of molding of plastic, it consists of producing the plastic component with the help of different machines. So injection molding machine, we have a process studied by us. Then after injection molding, next process was extrusion. Extrusion molding process was studied. Then it was blow molding. It was turn of blow molding. And then in the blow molding process, there are 3 steps. First one is injection blow mold. Second one is extrusion blow mold. And third one is stretch blow mold. So today we are going to see compression molding. Compression molding process. Now in compression molding process, the usually compression molding process is used for thermosets. Thermosets, you know that properties of thermosetting material is when you are going to heat it, it will become hard and set at that strength. Once again, if you reheat, it will not alter its properties. So thermosetting materials are the materials in which plastic materials in which we are going to shape that material by some process of heating cooling, and once you set, that will remain there as it is. So compression molding process consists of, it is like a forging operation you have seen, closed die forging. So what was there in closed die forging? So there are 2 dies, one is lower jaw, another is upper jaw. So material is kept in between and then you are going to press it. Okay, material is completely confined into the shape of die. So material, when it is completely confined into shape of die, it is not a metallic part as like forging. So the working style similarity I have told. Here we are dealing with plastic material, that is thermoset. The best application is phenol formaldehyde called as a bakelite, used for electronic switches, electrical switches, and other similar components. Now, what is the difference between molding and this compression molding? So the main difference I told that the difference is this is used for thermosets and that was injection molding was used for thermoplast. But in the operation also there is a big difference. In injection molding, you are plasticizing the plastic in the machine before it go outside the nozzle into die. Once you have plasticized the plastic, then that plasticized plastic you are forcing it through the nozzle. Nozzle is connected to die and plasticize the plastic directly injected into the die. So try to understand the difference in the working. In compression molding, you are putting your material, whatever stuff you have, into the half of the die, maybe suppose female die, and then you are going to heat that mold. So mold heating is important step in compression molding. So mold is heated. Once that plastic material will little plasticized, then the upper jaw forces it slowly. The pressure is not, so when you start pressing the upper jaw, cavity have some shape and material stuff is kept in between. When the upper jaw forces, then that material will start flowing into the whatever space available. It is not flowing as like injection molding. So here, as soon as the upper jaw start taking the position of cavity, material will start flowing in the gap, and once upper jaw is closed, whatever gap between upper jaw and lower jaw is maintained, that is shape of your component, and it is remain there for some time. Cycle time for compression molding is more. That's why it is costlier process. So it is kept there for sufficient time, and then we are going to wait. And after waiting some time, when upper jaw is removed, then that product with the help of ejector pins is removed and taken it away. So very simple process. That's why I have related it to the working like closed die forging. So upper jaw, lower jaw material is kept. The difference that here we are going to heat the mold so that that mold will preheating. There are two steps in compression molding. One is preheating and then pressing. So once you apply the pressure, plastic material will flow into the gap. Usually thick components are produced by compression molding. Injection molding is suitable for producing thin components. Compression molding, little thick components are produced. So this I will when I will draw the schematic diagram, you will understand. So before that, you just write down the principles. Compression molding is used for manufacturing of thick walled components. Compression molding is used for manufacturing of thick walled components which cannot be plasticized in the extruder. So plasticizing is difficult. That's why which cannot be plasticized, which cannot be plasticized into extruder. Compression molding is used for manufacturing thick walled components which cannot be plasticized in the extruder. Next line, it is one of the important molding process for thermosets. It is one of the important welding process for thermosets. And then there are two steps. First is preheating and second is pressing. Now see here. This is a raw plastic material which is kept in the lower die. This is the upper jaw. And now when it is closed, how it is looking? Check. Please draw this figure. So once you close it, heat and mold. This is heated mold, and you can take product out with the help of ejector pins like this. can see this product. Now I have shown you from this view. Okay. So this is the view which I have shown. So it may have some depth. It may have some depth. Just I will hatching pattern. I will rewrite so that you can. I will not hatch. Only this part I will hatch. So it has some depth inside. From this side, we have shown. So this thick component like plate, like tray. So what are the usually applications for this compression molding? The shapes which are similar to like this. So I repeat once again, there are two steps in compression molding. First one is preheating and second one is pressing. The component is kept here in the bottom die. You can see it as a female die. And then there are heaters. You can show this symbol. Mold heaters are there. So you can provide the heating operation. Once you preheat the component, the plastic which is kept in the die get reached into plasticized zone, and once it will reach in the plasticized zone, pressing will be carried out, and after preheating, next step is pressing. It is kept there for sufficient time till the material will flow into the gap between upper die and lower die, and then it will remove to get the product. Draw this figure. Write one statement. This process is not economical due to long cycle time. Because such, whatever I am dictating, see, already I am providing notes, no issues. But such important statements which can be part of MCQ. That's why you make star. This is uneconomical. It is uneconomical due to long cycle time. Full stop. It is widely used for thermosets like phenol formaldehyde in bracket bakelite. Advantages. Low cost. Second, more uniform density. See, what is logic in uniform density? Please think over it. What is logic in more uniform density? Try to understand. You are pressing it. So because of pressure, whatever gap only provided between upper jaw and lower jaw, material get flows. So automatically, due to uniform pressure, density in the component will be uniform. Uniform shrinkage due to uniform flow of material. Uniform shrinkage due to uniform flow of material. Internal stresses are minimized. Internal stresses and wrapping, WRAPPING. Internal stresses and wrapping are minimized. I will tell logic behind this statement. In injection molding or extrusion molding, what happens? You are forcing the material. So when you force the material will go inside and then immediately you are taking it out. Cycle time is less. If there will not be proper cooling, what will happen? That material, suppose this cylinder, small pipe I have produced. If there will not be proper cooling, there will be distortion. Asa वाकडा तिकडा होईल pipe. Are you getting my point? Due to improper cooling, it may happen. So wrapping, distortion is a possibility in that process. Here, you are keeping it, holding it for sufficient time. So there is no chance for wrapping. Tightly packed components between upper jaw and lower jaw, and once it gets cooled, you can remove it easily without wrapping and distortion. That is the important advantage of compression molding process. Then every process has some disadvantages. Next line, write down disadvantages. Curing time is large. This is one of the important disadvantages. Curing time is large. Uneven parting line may be present. Uneven parting line may be present. And what is one you can make more important, third disadvantage? As this is thermoset, try to understand. Scrap cannot be reprocessed. Make star and write. I hope you understand the meaning of this third statement. Whatever scrap will be produced in compression molding, it can't be reprocessed. Why? Because it has undergone heating cooling cycle. Once thermoset will undergo heating cooling cycle, it will become hard and it will set at that property. You can't make it soft once again by further heating. So recycling is not possible in thermosets. So that's why whatever scrap is produced, that scrap can't be processed. So can write scrap can't be reprocessed. Then what care is taken here? Care is taken to keep scrap minimum. That's why this stuff is calculated using or considering the volume of the chamber or die. So correct volume is calculated and accordingly the material is kept. Otherwise, once you heat and cool it, it will become hard. Applications. Electric switches and buttons. Electric switches and buttons. Radio cases. Radio cases. Different electric parts. Different electric parts. Then dinnerwares. Dinner plates, bowls, big spoons, dinnerwares, etc. Now, I hope you have drawn this figure. I'm going to erase it. So, if some limitations are there of flowing of material, this compression molding is advanced to the next technique. So, that next technique's name is transfer molding. Transfer molding works on the principle of compression molding only. Only it is advanced compression molding, where the material is first plasticized in a separate chamber and then it is transferred through the sprue into the actual chamber and then it will be pressed. So Transfer molding is advanced compression molding principle. It works on the principle of compression molding only. So what is the difference in transfer molding and compression molding? In compression molding, material get plasticized in between the die, whereas in transfer molding, it is plasticized at separate chamber and then it is flown in the chamber through the sprue. That is feeding arrangement. So once I will draw the figure, you will understand meaning of transfer molding. Just remember, it is advanced compression molding. Advantage of compression molding are taken, and apart from it, disadvantages try to overcome. So next bit of today's class is transfer molding. This process, as works on principle of compression molding, it is also used for thermosetting plastic. Transfer molding. Right on principle. Transfer molding is very similar to compression molding. Transfer molding is very similar to compression molding, and it is developed to avoid disadvantages found in compression molding. Disadvantages found in compression molding. So already I told it is advanced compression molding. What is there? So see, many times exam a question was asked, as not only in subjective but also in MCQ and objective exam. Even if your exam, there are less chances for subjective. We don't know yet, don't come to conclusion. But if even exam will not be subjective, in case of objective examination, this transfer molding, compression molding, always few questions are asked. So what is principle exactly? On what principle it is working? What are the advantages? It is developed to avoid the disadvantages found in compression molding. It is developed to avoid disadvantages found in compression molding. Next line. In case of more complex parts, transfer molding is used. So there are little limitations in compression molding for more complex part. So if parts complexity is more, so along with principle of compression, the transfer principle is added in the compression molding, and hence molding becomes transfer molding for complex components. Again, it is of same material, phenol, formaldehyde and similar materials. Charge of, now write down next line. The arrangement of transfer molding is as shown in figure. Full stop. Charge of plastic is kept in heated cylinder. Charge of plastic is kept in heated cylinder till it becomes soft. Till it becomes soft. Next line. Then it is transferred. Then it is transferred to the mold. To the mold from bottom sprue. From bottom sprue. Arrangement. as shown in figure. Draw this figure. These are the heaters, round shape I have shown. Mold cavity. This is the screw. I hope you are understanding. I'm going to repeat the explanation once again. So this is the cavity, your desired cavity. In this cavity, you are going to get your object. But now, this is one more extra cylinder provided at the upper side of the upper jaw. And in that cylinder, your plastic to be plasticized is kept. And then these are the heating arrangements. So these heaters are also provided there. When it will start pressing, it will plasticize, and through the bottom side, wherever screw arrangement is made, it will start flowing. So initially it is heated till all material get plasticized. Once all material get plasticized, it is viscous. Try to understand. It is not like water. It is more viscous. It will not go easily through that screw. Are you getting my point? Plasticized plastic is more viscous. It will not go through this opening very fastly. Then pressing is required from the upper side. So that's why this upper jaw is pressed here, and then your material will flow here, and then it is kept for sufficient time in compressed position so that you will get your object after solidification. You will get your object after solidification. So in this way, this is little advantageous than only compression molding, and hence these heaters and other arrangements are separated from the mold. It sometimes finds difficult to work because one or the other, there are integrated things. So this, whatever bottom side of the jaw is there, we can say half of the mold is there. It is provided with ejector pins. Once you open it, you will eject the component, and then by the time here in the upper side, you can keep your plastic for plasticizing position, and then this cycle will be continued. So transfer molding works on this principle. So you can write statement: a plunger pushes, plasticize the plastic or semi-solid plastic. Plunger pushes, plasticize the plastic or semi-solid plastic into the closed mold, through the sprue with pressure. Now these molds you can provide cooling arrangement, and this material may get cooled here. The cooling arrangement is provided in the mold for making the solid component. Cooling arrangement is provided in the mold for making solid component. Okay, so friends, this is all about transfer molding. Today we have completed compression molding and transfer molding. Both processes are used for producing thermostatic component, thermosetting or thermosets. These thermosets, here every care is taken for minimum charge. Okay, sorry, minimum charge. Why I will not use minimum, I will use optimum charge. Charge means this material. Okay, so if you use optimum material for charging into the die, then there will be minimum scrap, because once a scrap will be more, it is very difficult to reprocess it. And both the process, transfer molding is little more advantageous than compression molding. Okay, this is all about plastic molding processes for thermosets. Okay. Just 1 minute, I'll take attendance.